Today we're going to take a look at the 2024 May paper of the AASL paper 2. And one thing I would like to remind you guys is anything other than exact number, we should be doing three significant figures. Okay, so let's take a look at section A there. This person claims that in Australia to have a longer years than rabbits in Spain. Okay, so we can see that the length of 1 year of each rabbit was measured and then recorded to the nearest mm. Australian people, the median was 80, interquartile range was 11. The recorded values for Spanish sample was shown in the box and whisker diagram. Okay, and then we have to complete this table and then to fill in these for each sample. So for median, for Spain, median, we're in the middle of the box. So let's take a look at here. This one, right in the middle, we have to draw a straight line down there. Okay. So after we draw here, it should be right around this place. So between 72 and 76, that should be 74. And since this line is between 74 and 76, so our answer for Spain should be 75. And then the interquartile range. The interquartile range marks down the Q3 subtracting the Q1. So what is Q3? Q3 is on the right-hand side of this rectangle, which is at 84, right? So this one marks down the Q3. And then where's the Q1? Q1 marks down the left-hand side of the rectangle, which is at 68. Okay, so that one is the 68. That's the Q1. Okay, so our interquartile range is Q3 minus Q1. So if we use our calculator, our Q3 minus Q1 will be 84 minus 68, which is 16. All right, then completed part A. Part B, justify your answer, compare the distribution of the lengths of the rabbit years in Australia and Spain using BI, the median. Okay, so for median, which one is bigger? So for median, we can then see the Australian sample is actually longer, right? So the median length of Australia, it's higher than that of Spain. Okay, by how much? By 5. Okay, and then by 5, we can then have the implication. What is the implication? That means on the whole, we will expect the rabbit year length in Australia, it's longer than that of Spain. Okay, so this marks down the first comparison with the median. Now part B2, we have to compare the interquartile range. Okay, now you know that the interquartile range compare the spread of it. Okay, if you have a smaller interquartile range, that means the middle 50% is going to be very condensed. Okay, and vice versa, if you have wider interquartile range, that means the middle 50% will be more spread out. Okay, so which one do we have a larger interquartile range? It's the Spain, right? Okay, so we have to say the interquartile range in Spain, it's higher than that of Australia. By how much? Seems as if by 5 again, right? Let's check. Yes, by 5. By 5. By 5 mm. Okay? What does it mean? That means the spread, this is a key word, okay? Please keep that in mind. The spread of the rabbit years length in Spain, it's wider, okay? It's wider, okay? And on the other hand, what? The spread, what is that? The spread of rabbit year length in Australia, it's more consistent. It's more consistent. Okay, that marks down the question 1. Okay, so let's move on to question 2. Okay, this person buys a car for $35,000 and then the value decreased by 15% the first year. Okay, find the value of the car at the end of the first year. So you will expect it like this, right? Now, we can see that after the question, it will be many more years, right? But let's mark down, this is where it buys the car, first year, second year, third year, so on and so forth. But all we can tell is after the first year, it is dropped by 15%, okay? So then we can have 2A, so $35,000 times 1 minus that 15%, which is 35,000 times 0.85. So use our calculator, 35,000 times 0.85. We can then gonna have the dollar sign first, 29750. Part B. After the first year, the value of a car decreased by 11% in each subsequent year. So that means after the first year of minus 50%, later on it will be dropping 11% every single time. So will be like this. Okay? And then the question asks, find the value of the Darren's car in the 10 years after he buys it. Give our answer to the nearest dollar. So may I ask you, in 10 years, how many years has it undergone that minus 15%? And then how many years is it minus the 11%? So if you think a little bit here, the 15%, this one, it undergoes for only 1 year, right? However, if it lasts for 10 years, right? The first year, that's going to be minus 15%. That means the remaining 9 years here, the 9 years will be the minus 11%, okay? So in our answer, we have to write it as this. In 10 years' time, it will be $35,000 times the first year decrease, 1 minus 15%, okay, times 1 minus 11%, okay? And then to the power of 9. But if you want to show steps, you can then still write it as 10 minus 1, okay? So we have the first answer, which is 35,000 times 0.85 times 0.89 to the power of 9, okay? And for sure, just because we have the answer from part A, we can copy it down first and then times 0.89 to the power of 9. Use our calculator, directly press multiply 0.89 to the power of 9. Press enter, we're going to have 10,0423.1. So round it to the nearest integer, we're going to have 10423. Okay? So that's part B. Then we're going to have C. Before C, let's read this one. When Darren has its own card for n complete years. The value for n is less than 10% of its original value. Find the least value of n. Now, notice one thing. If we don't know the answer, we have to guess the answer. The least value of n, that means we would expect something to be an inequality. And it will be n bigger than something, something, something. Okay? This is something that we would expect it to happen. This pattern. Okay? N bigger than, because it's at least. For example, n is bigger than 7.5. That means n is at least 8, right? This is the question style. But first of all, we need to set up the inequality first. So it says for n complete years, then the value of the car will be 10% less than original value. So, but from this timeline, we can tell that for the n complete years, other than the first year is minus 15%, the remaining years will be minus by 11%, right? So for example, for 6 years, you're gonna have 5 years gonna be minus 11%. For 20 years, you're gonna have 19 years, it's minusing 11%, right? So for n years, for sure, we can expect to have an n minus 1 number of years. That is subtracting by 11%. So let's set it up first. We're gonna have part C, $35,000 times our 1 minus 15% the first year, and then times 1 minus 11% happen for n minus 1 years. Okay? And then it has to be less than, so we just follow what it's being told, less than 10% of its original value, which is 35,000 times 10%. Okay? So from the question like this, we can then divide it by 35,000 on both sides, right? Divided by 35,000 on both sides. Then we can gonna have what? 0.85 times 0.89 to the power of n minus 1 less than 10%, right? 10% means 0.1. Okay? Divide 0.85 on both sides. 0.89 to the power of n minus 1 will be less than 0.1 over 0.85. Now here's a problem. How can we bring the power, that means our subject, back down there? We can then take log on both sides. So if we take log on both sides, how can you write it? We have to write down log, okay, the entire thing, right? So 0.89 to the power of n minus 1 less than what? Take the log of the entire thing of 0.1 over 0.85. Now we can then bring our power, this one, back to the front. This is the log property, okay? So after we bring it down to the front, we're going to have n minus 1. Don't forget the bracket. So log of 0.89 less than log of 0.1 over 0.85, okay? So the next step for sure is to divide by log 0.89. So after we divide it, can I just directly write in this way? N minus 1 less than log of 0.1 over 0.85 over log 0.89. Does it have any problem when I write in this way? There's actually one simple thing. Because if you notice, on the start of part C, we said n has to be like bigger than, right? Bigger than number. But if I write in this way, and in the next step, if I plus 1, it will be n less than a number. So that means something is wrong when I am trying to divide this log 0.89, right? So let's try to type log 0.89 in the calculator to see what kind of numbers that we can have. It is a negative number, okay? So that means from the second last step to this step, the thing that is undergone here is we have to divide a negative number because log 0.89, this one happens to be a negative number, right? If we divide it by a negative number, the action that we have to do is we have to turn this one into the other direction, okay? So the correct way that we should be doing is we have to do this arrow when we are trying to divide the log 0.89 on the other side. And then furthermore, our n will be bigger than log bracket 0.1 over 0.85, close bracket, over log of 0.89, okay, and then plus 1. So use our calculator. So log of 0.1 divided by 0.85, okay, press enter first, and then divided by log 0.89, and then press enter, and then finally we have to add 1. So our n, it's bigger than 19.364 something something something. So therefore n, it's at least 20. Question 2 completed. Okay, move on to question 3. Question 3. So read the question first, okay? Don't try to read everything up there, because with the diagram, you have some information down there. Watch the A first, okay? Find the radius, okay? So that means the radius is missing. So we can then quickly label the radius down there. This one is actually the R, right? The radius. Again, and then we try to see what kind of any other information is being given in the description above. All right, so the vertical height of 20 meters, which is given, so we don't care about that. Okay, so cross that out. And then Oliver stands 5 meters away from the base. This is 5 meters, which is also given. So we can cross that out as well, to the base as well, okay? His eye level is 1.8 meters above the ground, 1.8 given. No need to care about that. And then the angle of elevation of from his eye, it's 58 degrees. So this is also given. So we don't need to care about this part anyways. All right. But how can we read this one? So if we can draw this diagram out, let's try to draw the triangle like this. Okay. So we can then have this one that's actually going to be 20, right? And then now here, that's going to be r plus 5, right? Because that is from the middle to where this person is standing. Then this is r, this is a 5, right? But the thing is, this angle is not 58 degrees because the whole vision got raised up by 1.8 meters. So technically, that means this triangle, the height of this triangle is not 20, but that's 20 minus 1.8, right? Because the whole thing got shortened by 1.8 meters, right? So because we want to set the corner, this part at where his eyes is looking at, okay? So if this is a 58 degrees, then the question is, we have to know this is 20 minus 1.8, okay? So we say, hey, isn't it this one raised it up? Then this one is no longer R. This is no longer 5. Yes, but then the thing is, if you just directly bring this line up, okay, bring this line up, it's actually the same. It is raised up vertically, okay? So if the bottom, this one is called R plus 5. If it got raised up vertically, this one is also called R plus 5, okay? And now, what kind of stuff that we know? If you're given an angle and your unknown is in one of the side, and it is a right angle triangle, usually we're going to use sine, cosine, and tangent, right? So what have we learned from sine, cosine, tangent? You should have learned one thing called SOHCAHTOA. What is SOHCAHTOA? Let's write it out here. So S, okay, S which is OH, right? Ka, CAH, and then TOA, T, and then OA. So now our vision is from this 58 degrees, okay? So from this 58 degrees, this is the side and this is the side, right? In the 20 minus 1.8, this is the opposite of it. So this is the O, okay? And then this one, it is on the one of the legs, okay, that is next to the 58. So this one is called the adjacent, okay? And then the H is the height. It's not height, it's the hypotenuse, okay? So we have O, we have A. But looking at this one, we should use tangent, okay? Tangent, this one. So let's just use tangent to solve the question together. So part A, tangent of 58 degrees equals to what? Equals to opposite over the adjacent, okay? So which is 20 minus 1.8 over r plus 5. All right, so 20 minus 1.8 using the calculator, we have 18.2. So tangent 58 degrees is equals to 18.2 over r plus 5. So the r plus 5, we swap the bottom to there. So r plus 5 will be 18.2 over tangent 58 degrees. Subtract 5 on both sides. You're going to have r equals to 18.2 over tangent 58 degrees minus 5. Okay, so now we can then use the calculator. But there is something that you have to bear in mind. Let me demonstrate it once, okay? 18.2 divided by tangent 58 degrees. Oh, and then minus 1. Wait, this is negative. Can you see on my left-hand side calculator? Why this was negative? And you got panic, and you don't know what to do. Do you calculate anything wrong? Yes. The thing is, please go to mode. Can you see here? This is in radian mode. But this question, clearly you can see this one is in degrees, right? So before you do this question, or if you figure out there is something wrong with your trigonometry calculator function, please check if it is in radian mode or in degree mode. In this case, we have to change it back to degree mode first, okay? So after we change to degree mode, we can then repeat our process one more time. 18.2 over tangent 58. Now you can see the answer is actually 11.37 something. Then we minus 5, and r is equal to 6.37. So r is equal to 6.3726. Okay, please make sure you have this question done in degree mode, okay? Degree mode. Okay, so the radius, now, it doesn't specify anything, so we have to correct to 3 significant figure. So our radius is equal to 6.37 meter, okay? Part B, find the volume of the entire thing. So part B, the volume, which is pretty straightforward, it's 1 over 3 pi r squared times the h, okay? So our radius is what we have just found, which is 6.3726, just like that, square times the height. Now, this height is talk about the entire cone. So that means we have to use the complete 20 meters, okay? So times 20, okay? So use the calculator, and then we can put 1 over 3, so 1 divided by 3, and then enter first, and then times our pi second, this, times the answer, and then this one we have to square it, and then we have to times 20. Okay, so our answer is 850.54, which is equals to 851 meter cube. Okay, 3 significant figure. Okay, so question 3 completed. Question 4. So this one is a normal distribution question, mean 10, standard deviation 2. So the probability of x that is more than 1.5 standard deviation above the mean. So I would suggest all of my students, when they're doing normal distribution, you have to do it in this way. Okay, draw it out first. This is a 10, standard deviation is 2, right? And this question says it has to be 1.5 standard deviation above the mean, which is on the left or right hand side. It's higher, right? Higher, that means we should put it on the right hand side, okay? So on the right hand side, and it's higher, and then this area, it's our answer to be found in part A, okay? So how should we do? Well, first of all, one thing we need to clarify is we don't even know what kind of point that is, right? Is it 11? Is it 12? Is it 15, 14, 15? We don't know, okay? But we can calculate first. It is 1.5 standard deviation, right? So our mean is 10 plus 1.5 standard deviation times our standard deviation, which is 10 plus 3, which is 13. Oh, sorry, I should use a black pen, okay? So that means this point is actually 13. And then we can then find our part A answer by the probability of x is bigger than 13, okay? So how should we do it? We have our JDC, then we can then use one thing, which is press second, and then vars, okay? Now you get to the menu, you can see there's normal PDF and normal CDF. Which one should we use? Should we use PDF or CDF? The answer should be CDF, because what is mean by PDF? Now PDF, the P stands for a point, okay? CDF, you can then understand it in a way that is cumulative. Okay? So in this case, we are trying to find the cumulative area instead of a particular point that this particular thin slice taken how many percentage of the entire area, okay? So we are finding a bunch of areas, okay? So we have to use CDF. So we can have to write that as normal. You can directly write down it like this, normal CDF, and then on the calculator, let's press it, okay? The lower bound, which is 13, right? Okay, that's what we have just found. So 13, and then we put a comma there. Upper bound, now on your question paper, you should write infinity because it's right to the right-hand end, right? Right-hand side end. But on our calculator, let's just put 99999, okay? It's easier. Put comma, your mean is a 10, your standard deviation is 2. Same, you put it on your question paper. Press enter, you're gonna have 0.066807, which is equal to 0.0668, okay? Correct to 3 significant figure. Okay, for part B. So question 4, we have to understand what is mean by x is more than k standard deviation, right? What does it mean by k standard deviation? K standard deviation above the mean is 0.1. Again, it's on the right-hand side of it, right? So if we have to draw it out, let's draw it in this way. So that's going to be a 10, right? And then this part is actually a k. And then on the right-hand side, this part is actually 0.1. So just now we have a point, right? We have a point, then we have to find the area. Now we have to do in the reversed way, which is we're given the area, but we have to find the k, okay? We have to find the k. So that means we have to write down probability of k bigger than x is equal to 0.1 first, okay? And then this case, k will be equal to what? We have to use another thing called inverse norm. So still put second, vars, go down to number 3, inverse norm, okay? Now, it varies between different calculators, so you have to write down inverse norm first, okay? Open bracket. Now, some calculators, you can directly put in 0.1. But in this case, my calculator doesn't support that. So we have to key in the area from left-hand side covered to the right-hand side where I want the point to be. So in this case, it's from the left-hand side that it's here, cover up to the k. So this particular area is 0.9. So on my calculator, I have to put 0.9, okay? And then comma with my mean 10, and then comma 2, okay? But on my question paper, I can still write it as 0.1. Still put 10, still put 2, but then you have to specify where the tail is. The tail means where the area is covering, okay? Is it on the left-hand tail or is it on the right-hand tail? In this case, it's the right-hand tail, okay? So, and then we press enter. The k is 12.5631, okay? 3 significant figure, 12.6, okay? So question 4 completed. Okay, question 5. So this is a solenoid diagram, okay? That means a sine formula or sine function, okay? So this is, we have to find the smallest value of t when the particle changes direction. Then there's one thing we need to understand is what kind of graph is being provided. This time we provided with a VT graph. not a displacement time graph, not an acceleration time graph. This is a VT graph, velocity time graph. Velocity time graph, what kind of special things that we will expect? It's if it appears to be in the area that it's below the x-axis, okay? Let's say these two area, okay? Moving in the negative direction, that means it is moving backward, okay? But if the things is moving in the area that is above the x-axis, let's say here, this is positive, right? That means this is moving forward. Okay, understand? So now, what does it mean by, what is the smallest value of t when it changes direction? Changes direction means from negative velocity to positive velocity, or from positive velocity changes to negative velocity, okay? So now it changes direction. Let me write it down first. It's from either from negative velocity to positive velocity, or from positive velocity to negative velocity. All right. So changes direction is like this. So we have 2 points. Okay. We can then see it's actually either this point or this point, right? 2 points that we can see there. Okay. So smallest value, that means we're looking for this one. All right. So now we have to use our calculator again. But in this case, I have to remind you one more time. You can see the formula, it's 0.5t, right? If the input here is a pretty small number, let's say between -2 to 2 to +2, most likely, or whatever you have learned, it should be in radian mode, okay? Radian mode. So be careful. So now please set your calculator into the radian mode first before you do anything, okay? And then press the top left corner of your calculator, y equals to, okay? Oh, in this case, I just key in this formula already, okay? 2 sine 0.5, we don't use t, but we use x because it is an xy graph, all right? So after we key in, then we just press enter, then click the top right-hand corner button, graph, okay? So you can see that it's actually quite matches with the graph that we see here. The first t that it changes direction will be the first 0 or the first x-intercept, right? So let's press down second, trace, and then go down, press number 2, 0. Okay, it will ask you to find the left bound. Okay, you see a little red line on my calculator. Let's just set the left bound like right there. Doesn't matter. As long as the right-hand side right bound is over that particular x-intercept, let's press enter. Then you can read it as 1.68695. So t equals to 1.68695. You can then from GDC, your graphic calculator. All right. So for part B, okay, find the the displacement of the particle is measured in meters from that means from the 0, right? Find a range of value of t for which the displacement of the particle is increasing. Now again, what does it mean by displacement is increasing? That means it is moving forward, right? Moving backward, the displacement is not positive. It's not increasing, but decreasing, right? You're moving backward, okay? Moving forward, that means your velocity, it's above 0, which means we have to look for the pink part that we just discussed here, okay? We have to look for the interval for which the VT graph is above 0. So just now we figured out the first t, that is right there, which is 1.689695, right? 1.68695, 1.68695, okay? Then, on the right-hand side for this one, how can we find it? Again, use the calculator. Press second, trace again. Press 0. This time we use slightly switch to the right-hand side. Press enter, and then make sure you cross the 0. Press another enter. Now you can have this point at 6.11857, okay? So find a range of values of t. That means as long as the time is between 1.68 and 6.1 something, then they are moving to the positive direction because the VT graph, the area is positive. Okay, so let's write it. So the t is 1.689695 less than 0 or less than t less than 6.11857. Or we can then simplify into 3-second figure, so which is 7.69 less than t less than 6.12. Part B done. Part C, find the displacement of the particle relative to the O when t is equal to 10. So this is how can we find the area from the VT graph? So if you remember the 3 stages, we will have the displacement, right? Displacement, velocity, and acceleration, right? From displacement to velocity, we have to differentiate it. From velocity to acceleration, we also have to differentiate it. If we want to reverse a process, we have to use one thing called integration, right? So integration in this case, integration in this case, okay? So now we have the velocity graph. We want to find the displacement. We have to use the integration. And does it give us the interval? Yes, because it's relative to O when t equals to 10. So that means from 0 to 10. For part C, let's write down the integral from 0 to 10 of this VT graph and make sure it is with respect to t, okay? And if you want, or if you're scared, you can directly copy down the equation, which is 2 sine of bracket 0.5. Make sure it is t, okay, plus 0.3 t minus 2. Close bracket then, dt. All right. Then use your calculator. This time press math. Okay, that math is under the alpha button. Okay, then goes to 9. This int thingy, okay? Sorry, let's quit this one first. Math and then number 9, okay? Integral from 0 to 10. The equation is 2 sine 0.5 alpha and then storage, which is the x, press the close bracket button, plus 0.3 alpha and then storage button, and then minus 2. Okay, and then press enter. Okay, this we're gonna have negative 2.1346 something something. We have to write it as negative 2.13 meter. Okay, so this one, it's the question 5. Okay, let's move on. Question 6. Question 6 is a comparison between two sets of data. Okay, comparison between two sets of data. Okay, so you see test A, test B, and then you are told to find what? You are told to find the correlation coefficient. Okay, so how can you find a correlation coefficient? First of all, we have to key in these two sets of data into our calculator first. Okay, so okay, first of all, we have to press the statistics button. Okay, so let's try to go to statistics and then edit. Okay, then you can have this table, and because of the time, I just inputted all the values for you. All right. So then now make sure you have the A on the list 1 and then B in the list 2. Okay. So find the correlation coefficient. We have to do one more thing. How can we calculate? After we completed it, we have to press down statistics again, move to the right hand side, and then choose linear regression line. Okay. Then you will ask you to choose the X list and Y list. Make sure your X list is L1, Y list is L2. Frequent list, skip it. Storage, red, EQ, don't need to do anything. Then you can see the bottom line in the calculator, which says 0.91901. So you can have this one as R equals to 0.901. Again, from GDC. Okay? So, and then part B, let's read it a little bit. The teacher uses, this person was absent for test A and another person was absent for test B. The teacher uses a regression line of y on x to estimate the missing score. Paulo scored 10 on test A. And then to estimate his score on B is to be 27 using the following calculation. Give a reason why this method is not appropriate. Okay, now this method is not appropriate because you see test A is ranging from around like 60 some 50 something all the way up to 100. But now you give me a 10 there, which means it's way lower than the range that is given. So we just say this one out. It's okay, okay? So we have to voice it out as, okay, 10, it's way below or way lower, okay, than the range of test A, okay, which resulted if it's not accurate enough, okay, and it's outside the range of it, okay. So we just mentioned part B. Now to part C, okay. Now another person scored 90 points on test B. He wants to use the score to test out the test A to be 87, okay, correct to the nearest integer. Give a reason why this method is not appropriate for this person as well. So this test is using test A to estimate test B. But in this format, you cannot estimate test A using test B, okay? It's A to B, because A is the input and B is the output, right? Now you give me the output, and can you directly substitute it backward to make the input visible? This is a no, okay? Because we have to write it down. For part C, C1, the reason is the C1 regression line. Regression line, it's of test, okay, A on test B. Oh, sorry, of test B on test A, because that's the Y result, right? Test B on test A, okay? However, in this case, not test A score on test B, okay? So we cannot invert it in this way, okay? So how can we figure out the correct linear regression model? We have to use the test B as the input and test A as the output, right? How can we do it? So we have the list already. We just have to swap the X and Y's only, okay? So let's use part C2, okay? So part C2, again, we have to click statistics, goes to the right-hand side, and then linear regression again. And now we have to add it a little bit, okay? Our Y list should be Y1 instead of should be list 1 instead of list 2. The X list should be in X list 2 instead of list 1, okay? So we swap it over, then we can then see the linear regression information, right? So our test result in the A is equals to 0.987124 times the B, the score in B, and then minus 3.219, okay? So in this test, this person scored 90 points, right? So we substitute the 90 into the B, okay? So we can say when B is 90, our A equals to 0.987124 times our 90 minus 3.219. Okay, so 0.897124 times 90 minus 3.219. Press enter. We have 85.622, which is close to 86. Okay, correct to the nearest integer. Okay, so that's how we get 86. Question 6 completed. Moving on. Okay, now welcome to section B. Section B, okay? We have this inverse function, and then we have this exponential function and the natural log function. All right. So let's find PQ. Now PQ, what do we have to do? First of all, we need to find where the P and where the Q is first of all, right? So we have to find the coordinate of P and Q, okay? Then we can use what? We can use the distance formula. Distance formula, okay? Which is x1 minus x2, which is this one. So the distance is equal to what? The x1 minus x2 squared plus y1 minus y2 squared, like this, all right? But how can we do these two equations, okay? We have to use the calculator again, okay? So let's go to y equals to, and then clear everything. Yeah, go up, cleared it. Input the two equations one by one, okay? So the first one, which is 3 over 2, right? Let's do put bracket 3 over 2, close bracket, okay? And then e, where's the e? E is second, and then the divide sign to the power of x minus alpha storage x minus 2. Okay, that's the first one. The second one is the inverse function, right? The inverse function, which is this one, right? So which is 2 plus natural log ln on the left-hand side of the 4, ln and then 2 alpha storage x divided by 3, and then enter, okay? So, and then let's click graph. So you see this graph, and it's pretty much of what we can see there. And then now we have to find the intersection, right? Because P and Q are the intersections. Press second, trace, go to number 5, intersect. The left bound, let's do it from left to right, okay? So from the left-hand side, press enter. Let's find P first, okay? The coordinate of this one, you can see that it's 2.66 something, the label in purple. So which is 0.26446. And the y coordinate is also the same, 0.26446. Okay? And then second, trace again, go to number 5. Okay, and then press enter left bound. Make sure it covers the point Q, and then press another enter. The next point here, the Q is 2.518 and 2.518. Okay? Then we can use the formula. Okay, so they do not give any space. Okay, let's do part A first. Part A first. Oh, show that the inverse function is given by that. Okay, we forget to do part A. So let's do the f of x. F of x, part A. F of x is equal to what? It's equal to 3 over 2 e to the power of x minus 2, right? Which means y is equal to 3 over 2 e to the power of x minus 2. Swap the x and y's because we are doing the inverse function. So x equals to 3 over 2 e to the power of y minus 2. Okay? Now we have to make use of the, let's move the 3 over 2 on the other side. You're going to have 2 over 3x equals to e y minus 2. Now, this case, we have to take the natural log on both sides. All right? So in the next step, we have to write down like this. Natural log of our 2 over 3x equals to natural log of our e to the power of y minus 2. Then we can then bring the power down there, right? So natural log of 2 over 3x equals to y minus 2, make sure bracket it, natural log of e. If you remember, natural log of e is equals to 1. So that means ln 2 over 3x equals to y minus 2. And the y is equals to natural log of 2 over 3x plus 2. Therefore, f inverse of x equals to ln 2 over 3x plus 2. That's how I prove it. All right, that's for part A. Sorry we didn't figure that out All right, and then, oh, sorry, we have to write the exact format, okay? So, which is 2 plus natural log of 2x over 3 in this way. Yeah. Let's try to make it as similar, as close to what it's being given. So for part B, we have to find PQ, right? PQ we just found. For part B, we have the P's coordinate, right? P's coordinate are 0.26446 for both of them, 0.26446, right? For Q's coordinate are how much? Are 2.518, 2.518, and then 2.518. So therefore, QP's distance is what? Is the square root of the difference, right? So, which is 2.518 minus 0.26446 squared plus 2.518 subtract 0.26446 squared, right? Of course, we're going to extend a little bit longer. Okay. So why? Because like this, because we have 2 points, right? This is P, this is Q. We want to figure out the difference between them, right? Okay, so this is the y difference, and this is the x difference. Okay, and then we use Pythagoras theorem to apply in here. Okay, so let's use 2. Okay, let's quit this one first. Quit 2.518 minus 0.26446. Enter, and then we squared it. Okay. And now we squared it because can you notice is actually this and this is the same. So we can actually times 2 because itself is the same. Itself plus itself means itself times 2. So press enter. Then we take the square root. So second x squared and the second minus sign answer. So QP is equals to 3.1869. 3 significant figure. So QP equals to 3.19. Okay? C1, write the expression for gx. What is gx? The graph of f is reflected in the x-axis and then translated parallel to the y-axis by 5 units in the positive direction. Now, this one is pretty tricky because what does it say here? Parallel to the y-axis. That means it goes like this, right? Parallel. This is y-axis. Parallel is also like this, right? Goes 5 units in the positive direction. Parallel goes positive, that means moving up. So if you want to read it as an English, what is this? Translator blah blah blah. It means move up by 5. Okay? So the whole equation, now if you have the f of x, right? What is the graph transformation? Flip over the x-axis, that means we have to flip the entire thing. Apply the negative sign in the front of it. Then they flip it upside down. Then the whole thing has to add up by 5, right? Means shift up by 5 units, okay? This is what we're going to do. So write the expression for gx. So where is f of x? F of x is, we have to write down C1 first. C1, g of x will be equals to what? It will be equals to the negative of the entire thing. Then at the end we add 5, right? The middle that we should do is the f of x. So let's just copy it down. 3 over 2 e to the power of x minus 2. Okay. Then does it have any other things to work on it? No. So let's just remove the bracket. Negative 3 over 2 e to the power of x minus 2. Whole thing plus 5. That's it. Okay. Find the domain of G. The domain of G, let's think about that. The domain of G. So the original graph looks like this, right? Okay, if you think about that. Let's just use the graph to think it for us. It flipped upside down. Okay, it flipped upside down. So that means it is still, now be careful, it's not from negative infinity to positive infinity. In the question, it's specified for you. It is between 0 and 4, okay? But if you flip it over the x-axis, it is still ranging between 0 and 4, right? Because the graph looks like this, right? Originally it's like this. Now you flip over, which is like this only. but it's still ranging between 0 and 4, right? And then if you shift it up by 5, 1, 2, 3, 4, 5, it is still between 0 and 4. So that means the domain doesn't change, okay? Which is still between 0 and 4. So the domain of G, let's just write it as, you can write in two ways, either square bracket 0, 4, close with square brackets, or you can write it as, okay, 0 less than or equals to x, less than or equals to 4. That also works, okay? Part D. Solve the equation fx equal to gx. Give my answer in the format of x equals to this, where AB is belongs to Q. Okay, so we have no choice, but we have to write it out, solve it by hand. Okay, because it said we need to give in this particular format. So calculator in this case it's not available. All right. So for part D, just give me more space. Okay, it says fx equals to gx, right? Let's just write it down first, okay? 3 over 2 e to the power of x minus 2 equals to negative 3 over 2. This is 3 over 2, yeah. E to the power of x minus 2 and then plus 5. Okay, we have to solve, right? What are we looking for? We're looking for the x. So our goal is to solve for the x, okay? So now we can do, what we can do is regroup the like terms on one side. So then we can move this one to here first, okay? By doing how, it's to add this whole thing, right? Because this is minus. If you want to move to the right-hand side, it's by plus, okay? So you're going to have 3 over 2 e to the power of x minus 2 plus 3 over 2 e to the power of x minus 2. And then equals to 5, all right? So 3 over 2 means 1.5. 1.5 of this plus 1.5 of this. If you add it up, you should have 3. 1.5 of 1.5 is a 3, right? So 3e to the power of x minus 2. See, they are the same family, right? So 1.5 of this expression plus 1.5 of this expression, and they're the same expression. So which is like 1.5 of the smiley face plus 1.5 of another smiley face, which will give a 3 smiley face. It's the same concept here, okay? Combine it as one single expression and make it equal to 5. Sorry, it should be with black pen, okay? We're solving for x, so we have to get rid of anything that is sticking to the x. So we have e to the power of x minus 2 equals to 5 over 3. Take log on both sides. ln of e to the power of x minus 2 equals to ln of 5 over 3. The power of a log expression could be brought to the front, right? So this thing bring to the front. We can then gonna have x minus 2. Make sure you have a bracket, then put ln e equals to natural log of 5 over 3. So ln e, as what we just said, it's equals to 1. So x minus 2 equals to ln 5 over 3. X equals to 2 plus natural log of 5 over 3. Okay, completed. So this marks down the question 7. Okay? So moving on to question 8. Now question 8, this one again, it is a sine diagram, okay? Sine graph. So let's read it first. What is it about? This is scary and Morocco or small islands in the Atlantic Ocean in the same time zone. And then this graph is represented by scary. Okay, let's just call it SS. Okay, the names is too difficult to read. Okay, let's call it SS. This is the SS graph. All right. So, and then for the first 15 hours, and then the low tide is 0.5, the high tide is 3.67. So let's just mark it down here. Low tide is 0.5, high tide like here, which is like 3.76. All right. These are some information. Okay, part A. The length of time between the first low tide and the first high tide is 6 hours and m minutes. Okay, find the value of m to the nearest integer. All right, so we don't need to worry about this, but we can use our good friend calculator. So go to the top left corner, y equals to, go to the top, clear the two graphs that we just finished. Let's just key in this function and make sure, now, in this case, your calculator should be in radian mode, unless you mess it up in the front. So make sure, okay, this is in radian mode, okay? So go back to the equation. Let's just put in 1.63 times sine of 0.513 open bracket x minus 8.2 close bracket, and then plus 2.13. All right, and press enter. Okay. So now the time between the first low tide and the first high tide is 6 hours, right? So the first low tide, can I think it as a straight line like this? This is 0.5. That means y equals to 0.5, and y equals to 3.76. Okay. So let's just key in these two lines into it, but let's just do it one by one so that to avoid confusion. So y equals to 0.5, let's say. Enter first, okay? Click graph. Now you can see there's an intersection, right? So let's just use second trace. Go to number 5, intersect, okay? And then the left bound, click enter. Make sure it passes through there, and then press another enter. So when it is 0.5, the point is what? This point is 5.13802. Okay? Now go to y again. Go top. Change this 0.5 into 3.76. Okay? And press enter again. Go to the graph again. So we have to shift to the right a little bit. So zoom, let's just click zoom out. Okay. This one also works. So let's just press second trace and then number 5 intersect. The first high point should be around here, right? So let's just press it there and then press enter like this. Okay. So when it hits like the maximum point there, it will be around 11.26198. So for question A, the time between them, the number of hours between them, it's 11.26198 minus 5.13802. So it's just a math question. So 11.26198 minus 5.13802. Enter. So it's equals to 6.12396 hours, right? So, but we want the minutes, right? We want the minutes, so we have to minus the 6 hour first, and then times 60 minutes, right? Which is equal to 6 hours and 7.4376 minutes, okay? And therefore, the m to the nearest integer, that means m is 7. So, moving on to part B. Between two consecutive high tides, determine the length of time in hours for which the height is less than 1 meter. Okay, so how can we do it? First of all, let's just use this one again. Go up, clear it. We just press 1 is okay because that represents the 1 meter water level, which is like this. Okay, between two consecutive. Basically, we are looking for the time that is in between here. All right, and this is the 1. All right, so and then we can use the graph again. So you see this one is pretty zoomed out. Let's zoom in a little bit again. So now we can then figure out, basically we know there are 2 points, right? So let's just use second trace and then go to number 5, intersect again. So the left bound, we can then select it as, let's just put it here, okay? And then the right-hand side bound, let's just put it here. So the first point we can have here, it's 3.5692, all right? And then the next one, The next one is here. So the point is, again, second, trace, go to number 5, intersect, and then from here, goes to the right hand side, make sure it covers it, and then press enter. This is 6.70684, okay? I marked it out so that you can see it clearly. Okay, these two numbers. So, between two consecutive high tides, determine the length of time in hours for which the water level is less than 1 meter. We can then have the time is 6.70684 subtracting 3.5692. Again, calculator question. So quit it first. 6.70684 subtract 3.5692, which is equals to 3.13764, equals to 3.14 hours. 3 significant figures, okay? And then part C. For the rate of change of the height when the water is T equals to 13, give your answer in meter per hour. Now, this one is the height, not the VT graph, not the velocity time graph. So basically, we are looking for the derivative of this H graph at the 13, okay? So the idea behind it, we have to find the H prime of 13. But we do not perform this differentiation by ourselves. We use calculator. How can we use it? It's equals to, again, press math, goes to number 8, and derive, okay? So the derivative of what? The derivative of our equation, okay, which is, we copy this one down, 1.63, and then sine of 0.513, open bracket. Let's just still use x first. X minus 8.2, close bracket, and then close bracket, plus 2.13, and then the x value is 13. So let's just press enter, and the rate is 0.65, okay? So that's equals to negative 0.6506, which is equals to negative 0.65, and then that is in meter, right? So meter per hour, okay? So question 8, not yet completed because we still have more parts to do. All right, on the same day, there's water on the second island, Rockall. It's modeled by this. So we have to fill in the ABCD. So let's just model it quickly, okay? First of all, what is the original sine graph look like? The original sine graph looks like this, right? First goes up, then goes down. But it says all the ABCD has to be bigger than 0. This is minus C, minus a positive number, which means it has a horizontal shift, right? Horizontal shift from left to right. So you would expect the graph to shift to the right like this. And then, of course, we're going to fill in the rest of the stuff here, okay? So somehow, some way, the graph shall look like in this way, okay? And then let's just use our information. First low tide occurs at 2:41. So that means in this place, this is 2:41, right? The first high tide is at 9:02. 9:02. The low point is 0.4. The high point is 2.74. Okay? So we should have enough information to determine everything. Okay? So determine the ABCD. How can we do it? The A is the amplitude. Okay? Now it said, wait, isn't it? It's a reversed pattern here. It's a flipped it upside down. A is bigger than 0. So you do not have to think about it's undergone up and down flip, okay? It does not go in that way, all right? So for A is the amplitude. Amplitude is made by what? It's used by max minus the min over 2, which is 2.74 minus 0.4 over 2. 2.74 minus 4, enter, clear, 2.74 minus 0.4, enter, divided by 2, which is 1.17. And then what is another thing that will use the max and min is the vertical shift, which is the D. The D is made by the max plus the min over 2, which is 2.74 plus 0.4 over 2. So, which is equals to 2.74 plus 0.4 divided by 2, which is 1.57. All right. So now let's work on the B. Okay. Let's work on the B. The B is a period. So after you sketch this one, you can then tell, from the low tide to the high tide, this one should account for half of the period, right? Okay, this is half of the period. So that means let's find the length of here first, right? Which is around like 6 hours, 6.5 hours-ish. Then we times 2. So what is that in terms of numbers? It's, okay, for part B, okay, half of the period is equals to what? It's equals to 9 o'clock and 2 minutes, right? Which is 2 over 60, minus 2 o'clock and 41 over 60, right? Okay, so our period will be equals to 2 times the 9 of 2 over 60 minus 241 over 60. Okay, makes sense? Because the time that will account for the low tide and the first high tide will be half of the period. You double half the period, it will be 1 period. Okay, so let's just have 2 plus 2 over 60 minus bracket 2 plus 41 over 60, close bracket, enter, and then times 2. So the period is 12.7. Okay, so 12.7, how can we find the B? Our B is equal to what? Our period is equals to 2 pi over B, right? This is from the formula that you should memorize, okay? So B equals to 2 pi over 12.7. So 2 times our pi, and then and then 2 times our pi divided by our 12.7 is equals to 0.49473, which is close to 0.495, correct to 3 significant figure. Okay, now the last thing, it's about the C. How far does it shift? Now, we are not talking about how it's not, don't tell me it's plus by 2 hours and 41 minutes, okay? It's not by 2 point something. It is the middle point. How far does the middle point shift, right? Because sine graph is a graph that starts from the middle point. Now the middle point shift from the middle to right there. Where is it? It is right in between the first low and high tide time. Because apparently, if it is like evenly distributed, okay, then from the middle line to the first high tide, it should be 0.25 period. It should be a quarter of the period. It should be a quarter period. It should be a quarter period, right? So technically, between the first low and high tide, we take the time divided by 2. That should be the time of the middle line, right? So how can we find this particular point? We have to add it up, 902 minutes plus this 2 o'clock and 41 minutes, add it up, divided by 2. This is how far I shifted right, okay? So how can we find the C again? So our C will be equals to 9 minutes and 2 minutes over 60 minutes. 9 hours and 2 minutes over 60 minutes plus 2 hours and 41 minutes over 60 minutes divided by 2. Okay, so that means we have to use we have to just already type it, 9 plus 2 over 60 plus 2 plus 41 over 60. Okay, and then divided by 2. So our C is 5.8583, okay, which is 5.86. So that is for part D, okay. So for part E, when they are the same height, okay, when time equals to t, the two equation will have the same height. So that means we have to find the intersection. So we have no choice, but we have to use our GDC. Okay. So this one, we already found the first equation. We put it down already. So let's just key in the second one with the information that we just have. Okay. So let's just clear the y2. We then gonna have 1.17 sine of our b is 0.49473, okay, and then open bracket alpha storage x minus 5.8583 close bracket, and then we have to add the d, which is 1.57. Press enter. Let's go to the graph. Now they at the same height for the first time, which is we have to use second trace, go to number 5, intersect. The left side should be around 4, this one, right? So slightly press here, take the left bound. After you pass the intersection, take the right bound. We then gonna have the t. So for part E, we have to press h of t equals to this h of t, right? So therefore, the t is the intersection of the x, which is 4.16289. So t is equal to 4.16. Okay. So this is the end for question 8. So move on to question 9. Question 9. So the question 9, we have to find the two possible angles of OAB, okay, and give our answer in degrees with this setup, okay. OAB is this angle, right? So our OAB is here. So, but then what we have learned before is the ambiguous triangle shouldn't be this one, right? But it should be at the B, because the B, it could be extended in as it's being shown here, or it could be like this. It's still 25, and then the line still appears to be like this, right? Okay. So we have to find the possible two angles of the angle B first, okay? Then we use 180, subtract this 25 to figure out what the A is, okay? So how can we do it? We can use the sine formula, okay? So the sine formula give us what? Give us for A1, sine formula of sine, we have to use the, okay, sine angle ABO over, because that's the only angle with opposite, okay? For angle A, we don't have the opposite length, so we have to use angle B first, okay? So this is over 50, right? Equals to sine 28 over 25, okay? This is the sine formula. So the sine of angle ABO will be equals to 50 over 25 if we multiply 50 on both sides. So 50 sine 28 over 25. So which is equals to 2 sine 28, okay? So angle ABO will be equals to sine inverse of that, okay? So this one is in degree mode. Please change it to degree mode first, okay? So quit it, and then let's use sine inverse. So second, sine inverse of 2 sine 28, enter. So ABO, it could be 69.8748 degrees, or because it is a sine angle, it has two possible angles, right? Which is 180, subtract the answer, which is, or a 110.12518 degree, okay? However, we're not finding ABO. When ABO, it's 69.87. The angle of OAB will be equals to what? 180 subtracting this 28 degrees, subtracting this 69.8748. Okay? So 180 subtracting 28, subtracting this one, which is 82.125, which is 82.1 degrees. Or angle OAB will be equals to 180 minus 28 minus 110.125, which is equals to 180 minus 28 minus this 110, or 41.87, which is close to 41.9 degrees. Okay, these are the two answers. Okay, these are the two possible angles. Okay, and then hence we have to find the two possible areas. Okay, so the first possible area will be half AB sine C, right? Which is half of our AB. What is our AB? It's 25 and 50, right? Half of 25 and 50, and then sine of 82.125, okay? So 0.5 times 25 times 50 times sine of this 82 degrees, which is equal to 619.1, which is equal to 619. Does it got the area? Yes, meter square. Or area equals to half AB sine C with another angle, which is half of 25, 50, and sine of 41.87 degrees. So which is 0.5 times 25 times 50 times sine of this 41, okay? Which is 417.19, which is 417 meters square, okay? That's marked down the first two questions. Okay, moving on, B and C. Show that x squared plus y squared equals to that. And then we add another thing right there to show that the middle one is actually a 110. So how can we do it, okay? How can we do it? So we have a thing, and then it tells us the area of this OCD is 60, right? So that means this area covered is a 60. So we then have nothing else to consider. And then OC is the X, OD is the Y. Let's label that first. This is the X, this is the Y. So if you give me the area, let's just use that one then. So for part B, we don't know, but we can still do it, okay? The area equals to half AB sine C, right? So 60 equals to half of XY times sine of 28 degrees, right? So, and then times 2 on both sides, 120 equals to XY sine 28. That doesn't help, all right? Another thing that we can do is, this is a 10. Let's use a 10. Use this 10. The thing that we can use is the cosine formula. Okay, what is the cosine formula? The cosine formula is C squared. Okay, C squared equals to A squared plus B squared, and then minus 2AB cosine C, right? Okay, so our C squared is the opposite side. The opposite side is at the 10. So this is our C squared actually. This is our A, this is our B. Okay, so we're then gonna have, what is C squared, which is 10 squared, right? 10 squared equals to X squared plus Y squared minus 2XY cosine of 28 degrees. All right, now it looks like something that we can work on. So we can then simplify this 100 first, okay? So X squared plus Y squared minus 2XY cosine of 28, okay? So, but how can we relate these two things together, given that this one has a tangent? So let's think about tangent 28. tangent 28 is equals to sine 28 over cosine 28, right? That means if we want to replace the cosine 28, we can then use the sine 28 over tangent 28, right? And then we can use this sine 28, this sine 28 on the top will be equals to 120 over xy, right? So that means our cosine 28 is what? It's 120 over xy times the tangent of 28, okay? We can then make use of this to substitute into here. Let's see what will happen. So 100 equals to x squared plus y squared minus 2xy times bracket 120 over xy tangent 28. Now, xy and this xy can cancel out. 2 times 120 is 240. There we go. So we can then write down 100 equals to x squared plus y squared minus 240 over tangent 28 degrees, okay? So that means x squared plus y squared will be 100 plus 240 over tangent 28 degrees. Now we prove the B, okay? Now moving on to part C here, hence determine the two possible values of OC. Hence that means we have to use this one. So we have to write it down first. So part C, we have the equation of x squared plus y squared equals to 100 plus 240 divided by tangent of 28, right? And since we can't directly find this one by bare hands, we have to use our calculator. But we variables here. One is the x, one is the y, right? So we need to replace the y with something else, or at least state the y in terms of the x, right? So from the previous part, we can see here it's sine 28 is equal to 120 xy, right? What, 120 over xy. Now we can then rewrite a little bit. So let's write 120 equals to xy times sine 28. So then our y is equals to 120 over sine x sine 28, right? And then now we can then substitute this y into here to replace the y squared, okay? So the equation that we can use to do will be like this, will be x squared plus open bracket 120 over x times sine of 28 close bracket square equals to 100 plus 240 over tangent 28 degrees, okay? So, and then now we can then move on to our calculator part. So you can see here it's still in radian mode. So we have to go to the mode, make sure we change it to the degree mode first, okay? Then we can start inputting our equations. Now, we have two sides, right? So that means the first side, on the left-hand side, this is our y1 equation. So x squared plus open bracket 120 divided by open bracket x times sine 28 close bracket, close bracket, close bracket. And don't forget the square, okay? And our second equation, this one will be our y2, okay? So let's key in into our calculator. And after that, let's press enter. We can then click graph. Let it load some time, and then it will generate the graph, okay? So you see it's pretty zoomed out, right? And then we only see one graph. The next line is being generated onto the calculator. So we are looking for the intersections, right? And two possible links. So that means we have to zoom in a little bit to look for, is there any two intersections possible? So we zoom in a little bit. And of course, the calculator has to wait. So the middle line is the x-axis, on the right-hand side is the positive. So despite, you can see it should have 4 intersections, right? But we only have to focus on the right-hand side too. We have to zoom in a little bit more. Okay. And now you see two kind of like parabola, and we still need that straight line to pass through it, okay? So now we can focus on the two particular intersections, right? So we can press second, trace, go to number 5, it's intersect. Pick the first graph, which is the blue graph, press enter. Then you need to select the second graph, okay? So the second graph that you're going to select is the red graph, okay? So let's press enter to choose the red graph. Then you can see that the first answer is x equals to 13.13003. All right. Then we use zoom in again a little bit so that we don't get confused with the two intersection points. Okay. And after we zoom in, we can see clearly there should be two distinct intersection points. And the intersection point on the right hand side should be the second answer. Again, second, trace, number 5, intersection, and then choose a graph, enter, second graph, enter. Then our answer is 19.318. So our next answer is 19.46. So correct to 3 significant figure, we have x equals to 13.1 or 19.5. These two will be our two answers, okay? And hence the two possible length is what? The two possible length of OC is 13.1 meter or 19.5 meter. And this will be the end of the entire paper 2. Thank you.